Machine learning is just everywhere right now. You're writing your texts with machine learning, with ChatGPT. You're creating pictures. You are creating music. ChatGPT is going to give you a medical advice soon. But what is it and how does it work? In this video, I'm going to explain in simple words, and I will also explain why it started just now, because here's a twist. The idea is not new, it's roughly 70 years old already. And I will explain also how the cats were involved. So let's go step by step. What is machine learning? Well, that's when machine learns. And surprisingly, it does it very similar to humans. When you're explaining your child, for instance, what is a cat, you're not going to provide a fixed set of rules. You're not going to say it needs to be with 4 legs and with whiskers and with a tail, and that's a cat. Because if you would try to do this for every animal and every object, there would be just way too many rules. That would be too complicated. And so instead, you're just showing pictures, you're showing examples. You're saying this is a cat, and this is a cat, and this is also a cat, and that's a dog. And so the child will figure out on its own, just from looking at the data. And the machines do it the same way. You're providing lots and lots of examples, and it figures out on its own. As I said, the idea is not new. Artificial neurons were invented already in 1950s, and in 1980s, the backpropagation algorithm, which is basically the learning algorithm, was invented. And so in 1990s, in 2000s, the algorithms were already there, and the computers were already decent, but for some reason it didn't took off yet. So why that? And what happened in 2012? Because that was a turning point. And how the cats are involved. Before 2012, the research on artificial intelligence and on machine learning was mainly done in universities and academia on rather small amounts of data and on rather weak machines back then. And people were skeptical because the results were not so good yet. But then, 2012, Google comes and says, hey, why don't we just make everything bigger? We are Google, we can do this. We have resources. And so they spent insane amount of money, and they are training a huge, back then huge, neural network on 16,000 processors and on, let me look up, 10 million. On 10 million YouTube videos. And they're training that for full 3 days instead of just a few hours. And they are training it unsupervised, so they are not telling to search for specific things, they just give it the YouTube videos and let it run. And then the researchers looked inside of the machine, and what they found? They found that it has some particular neurons which are responding to cats. Not to dogs, not to people, just for cats. So the machine built its own cat detector on its own. And why is it important, or why is it interesting? Yeah, because, for instance, in your brain, you also have a cat detector. Scientists found that in human brain there are specific cells which are responsive for specific things, like one for your grandmother, one for cats, one for Jennifer Aniston. Yeah, I'm not kidding, really. For Jennifer Aniston, it's research published in Nature, and I will put link in the description. So that network trained by Google kind of replicated what human brain does in that regard. And it turned out that the size really matters. If you just make everything bigger, larger data, larger computers, then suddenly it starts to work. And somebody figured out that if instead of CPUs you use graphic cards, just the graphic cards for gaming, then you speed up the training of machine learning hugely. And now the graphic cards becoming bigger and bigger and bigger, and the machine learning went mainstream. But wait, you might say, that all happened like 10, 15 years ago. Why machine learning and artificial intelligence is taking off now so dramatically? Well, here's an insider secret. For many applications, you don't need to train from scratch anymore. You have huge foundational models which are already trained on detecting speech, detecting pictures, detecting humans in videos, and so on and so forth. And you can take them and just fine-tune them for your specific use case. And this is what many people are doing. And where is all the data comes from to train that big initial models? Well, many of them are trained like on the entire internet, on the whole knowledge of humanity, on pictures, on Wikipedia, on everything. And sometimes it's even you who are training that machines. For instance, did you ever click on "I'm not a robot" and you selected traffic lights and crosswalks and cars and buses and so on? Well, that's not just security. That's you helping to train self-driving cars and not even realizing that. That's quite clever to collect the data this way, no? So, and back to fine-tuning, again, this is similar to what happens in human brain. For instance, the child, when it's born, it has already some knowledge of the world encoded in their brain. The child can recognize voice, it can recognize faces, but then it starts to learn and kind of fine-tune its internal model of the surrounding more and more and more. And this fine-tuning never stops. For instance, when you learn to read, you start with simple pairs of letters, for instance, distinguishing A versus B. But then if you try to distinguish, let's say, B and P and D and Q, that requires to catch the details. So the machine learning learns like a human, but we're different, right? Right? Well, let's compare. Here's how your brain works. You have neurons which are connected together. They receive data, like signals from your eyes or your ears, and they process it. And when you're learning something, then the connections between neurons change. Now, here's how machine learning works. You have artificial neurons, which are connected, and they receive signals, for instance, from your image or sound or whatever, and they process it and produce some results. And when machine learns, then these connections between artificial neurons change. Do you see it? It's very similar, no? Well, your brain has 86 billion neurons, roughly, and approximately 100 trillion synaptic connections. And according to some gossip on the internet, because this is not a public information, modern networks like GPT-4 have somewhere between 1 and 2 trillion parameters, which are also the connections between artificial neurons. So, yeah, by number of connections, your brain is still about like 50 times larger, but we're already playing in the same order of magnitude, and the numbers are not really comparable because the architectures are not the same, they're different. But to be honest, the architecture of your brain and the brain of a cat is also different. But the main principle might be the same. Machine learning is mathematics. It's straightforward, simple, elegant. It learns from examples, it finds patterns, it improves through mistakes. The machine does it, the child does it, and you and my brains are also doing this. In Star Trek, there is a commander, Data, an android who is a part of the crew. And he spends his entire existence asking one question: who am I? And am I alive? So, I believe right now we are building our own datas. And they are writing poetry, they are creating art for us. But here's a question. If one day your computer are coming to you and asking, who am I? What are you going to answer? And how do you know if this question was real and if your answer was real and not both part of very advanced simulation? You know, our future is going to be very, very interesting. And right now, we're deciding what it will be. So, as a Ukrainian band, Tartak is putting this: let's live, let's search, and let's become better. Oh, and by the way, if you want to know why I'm putting the timer, check out my video on conquering the zombie tasks in your to-do list. Have fun!